Okay. You're sitting there wondering, who is this handsome fella? This is Carl Friedrich Gauss, one of the more famous mathematicians in history. He had a pretty exquisite mind, and one of the stories about his childhood is that he was so intelligent that he was a nuisance to his teachers. And one day his teacher said, "Add up the numbers from 1 to 100," and to keep him busy. He was 5, 6 years old at the time, elementary school, whatever the case may have been, and he did it like that. He figured it out that there's a pattern to how you can do that addition. So I'm gonna slide Carl down here. Sorry, Carl, and just give you an idea. If you had to add together, right, all of the numbers from 1 to 100. We can apply some of the properties of these series that we've been looking at with just a little twist, and that is, let's count backwards for a second as well, okay? Because rather than adding 1 plus 2 plus 3, which is probably what his teacher thought he was going to do, Carl's mind worked in a different fashion. He said, well, I know that the sum of 1 and 100 is 101. And at the same time, the sum of 2 and 99 was 101. And the sum of 3 and 98 is 101. ... Sorry, Carl. Don't mean to draw in your face here. But so we figured out that if you worked from the bookends, should we call it in, every pair of mirrored integers has a sum of 101. How many pairs of 101 are there? You would work from the bookends until you got to the middle and add 51 and 50 together, which is, of course, 101. There are 50 pairs of these. So he did 50 times 101 to get the overall sum. So Carl here came up with a great idea for adding what we call finite series. Right? What is finite? Finite is I'm not going to say the opposite of infinite, but what is infinite? Something that never ends. So something that's finite has an ending point. And if we have an ending point to a series of numbers, we can use this principle, this idea, to find the sum. Okay? But there's a much shorter way to write it down, and a much more general way, a formula, if you will, for doing this. And that's what this formula is. Okay, it's kind of intimidating, some of the notation here, right? We've talked about sigma. We've said that what we're going to do is we're going to add together, right? That's what this symbol means. We're going to add this a sub k. Okay, this is an arithmetic series or an arithmetic sequence. Okay. Starting by plugging in this number and ending by plugging in that number. Right? Starting by plugging in the number 1, getting the first term, and then stopping at the, quote, nth term, and you're going to see that quite a bit as we go forward. So there, in a sum of n terms, we can use this formula to calculate the sum. Okay, and in fact, there's a mistake here that I'm just now realizing. This should be n, right? So we take the number of terms in the sum, we take half of that. We add the first term and the nth term. So think about this. This is a model for what Gauss did, right? When he added 1 plus 2 plus 3, 98 plus 99 plus 100. What did we say? It was 50 times 101 to get this finite sum. How many terms are in this sum? 100, right? What's 100 divided by 2? 50. How did we get this number? We took the first term, which was 1, and we added it to the nth term, the last term, which is 100. So you can think of this a sub n as the last term in the sum. So add the first term to the last term, and then multiply that by half the number of terms in the sum. This is the formula for calculating a partial sum of an arithmetic series. I want to focus on this just for a second before we move on. The word partial means it's not complete, right? It means it's only a part of it. With arithmetic series, we can only calculate partial sums. We cannot calculate infinite sums because the numbers are either getting bigger or they're getting more negative as we move on, right? It's a linear pattern. We've discussed that. So in order to add these terms together infinitely, that's just not going to happen. Okay, the second point that I want to make, and this is going to come up, okay, you are going to see at some point a sum where we start at 0 and we end at 4. Now we've talked about this a little bit in terms of sigma notation. If we start by plugging in 0 and end by plugging in 4, how many terms are in this sum? Right? It's not from 1 to 4, it's from 0 to 4. So this sum, you may want to add something in your notes if you don't have it already. This sum has 5 terms. So you've got to be on alert. This is not necessarily the n that we use in this formula. Okay, you've been warned. This is not necessarily, we've got to consider where we're starting and where we're stopping. What number we start by plugging in and the number we stop by plugging in. Okay. Keep that in mind as you're doing some of these calculations.